Alright, boys and girls, welcome to our second lesson on radicals, day 2. Here we go. Okay, combining radicals, adding and subtracting roots and radicals. In order to add and subtract radicals, they must be like. Like radicals must have the same index, means this little number up here must be the same, and the radicand, the number inside the radical, must be the same as well. Okay, these are third roots now. These two things are third roots. Notice that they both have the same index. They're both third roots, and they both are third roots of 2. So basically, in this guy, I have 1 root 2 plus 4 root 2, which is going to equal 5 third roots of 2. In this guy right here, I have 1 third root of 2 minus 4 third roots of 2. Well, 1 minus 4 is negatory 3, so I have negative 3 third roots of 2. It would be just like doing 1x, or x, minus 4x is negative 3x, right? 1 puppy, take away 4 puppies is negative 3 puppies. It doesn't matter what kind of puppy we're dealing with. So, let's combine some radicals here. In this guy right here, I have 1 root 3 plus 2 root 3. My index is both 2. These are both square roots. My radicands are the same. So I have 1 root 3 plus 2 root 3, which is 3 root 3. In this guy on the right, I have 2 root 3 plus 2 root 48. Whoa! My radicals are not like. So the first thing we're going to do is see if I can simplify my radicals and actually create some like radicals. So this is in essence 2 root 3 plus 2, now 48, is equal to 16 times 3. So this becomes 2 root 3 plus 2 times root 16 times root 3. Well, we know that root 16 is 4. So I'm just going to switch colors here. I'm going to change my root 16 to a 4 right now. So I have 2 root 3 plus 2 times root 4, which is 2. I'm sorry, root 16, which is 4. So 2 times 4 is 8 root 3. So 2 root 3 plus 8 root 3 is 10 root 3. I have root 6 minus 2 root 24. Well, they're not like radicals, or at least they're not like radicals yet. Root 6, there's nothing I can do with that guy. However, root 24 is 2 times root 24, and root 24 is 4 times 6. Notice again, I'm choosing a number like 4 times 6 as opposed to 8 times 3, because 8 times 3, neither of those numbers are perfect squares. However, root 4 is. So I have root 6 minus 2 times root 4 times root 6. Well, root 4 is just 2, so I have root 6 minus 2 times root 6, okay, which is now root 6 minus 4 root 6, which is, we just did the problem like this, negatory 3 root 6. If I look at the guy on the right, I have 5 root 3 plus 2 root 7. That's a third root, or I'm sorry, that's a radicand of 3. This is a radicand of 7. There's nothing I can do with that. So this final answer, this is already simplified. These are unlike radicals. 5 root 3 plus 2 root 7. All right. Alright, so this guy right here, we have 3 radicals. Now we're going to see if we can add these or subtract or combine these. I have 1 root 3, right? There's an imaginary 1 there. 1 root 3 plus 2 root 3 minus 5 root 3. Just kind of think of this as x plus 2x minus 5x. These are all like terms. These are all like radicals. So 1 root 3 plus 2 root 3 is 3 root 3 minus 5 root 3. 3 root 3 minus 5 root 3 is negatory 2 root 3. If I look over here to the right, I have root 3's and I have root 10's. Well, root 10 I can do nothing with. Root 3 I can do nothing with. So I have 2 like radicals and 1 unlike one. So just 1 root 3 minus 5 root 3 is going to be negative 4 root 3. I still have the root 10 left over, so 2 root 10, and that's unlike, so there's my final answer. Neg 4 root 3 plus 2 root 10. And I can't do anything with those. Alright. You guys try these ones right now. Alright, you should have gotten for the first one 12 root 2. Okay, that's down here, right here. And I got that by saying root 2. And root 8 is 8. And 8 is 4 times 2. And root 50 is 25 times 2. So I have root 2 plus 8 times 4 root times root 4 times root 2 minus 25 root 25 times root 2, which of course we know the root 4 becomes 2, the root 25 becomes 5. So I have root 2, still the same old root 2, not doing much. 8 times 2 is 16, 16 root 2 minus 5 root 2. 1 plus 16 is 17, 17 minus 5 is 12, 12 root 2. 1 root 2 plus 16 root 2 minus 5 root 2 is 12 root 2. Up here, I wrote this above so I would have some room. I have root 30. Root 32 is 16 times 2. 16 is 4, so 2 times 4 is 8 minus 5 root 2. So I have root 30 plus 8 root 2 minus 5 root 2. There's nothing I can do with the root 30. However, these are like radicals. So I have root 30 plus 3 root 2. Okay, the rules for multiplying and dividing radicals is you can only multiply and divide the numbers inside with the insides and the numbers outside with the outside. Never, never, never multiply inside with outside or outside with inside. Only do inside with inside and outside with outside. Okay, so if we look right here at number 1, we have root 18 times root 2. So I can write that as root 18 times 2. 18 times 2, of course, is root 36. The square root of 36 is 6. Root 51 times root 51 is root 51 times 51. I have no idea what that number is, but if I think about it this way, root 51 times 51 is root 51 squared. Well, the square root of 51 squared is 51. Okay, so we look at this guy right here. Let's multiply the outside with the outsides and the inside with the inside. So I have negative 3 times 5. That's outside with outside, so negative 15. And now inside the radicals, I have 24 times 20. The last thing, 20. Good thing I can write and talk at the same time. 24 times 20. The last thing I want to do is actually multiply the 24 times 20 and make them bigger numbers. Instead, I'm going to break them down. I'm going to break them down into smaller numbers. So I'll do this in blue here. I have negative 15 times inside the radical now. 24 is 4 times 6. 20 is 4 times 5. So basically what I have here is I have negative 15 times root 4 times root 6 times root 4 times root 5. Well, this 4 and this 4, these root 4's both become 2. So I have negative 15 times 2 times 2. And now inside the radical still I have 6 times 5. Right? I have the root 6 and the root 5. So this becomes negative 15 times 2, which is negative 60. Root, inside the root I have 6 times 5, which is 30. Okay, over here on the right, I have 3 times root 24 times 2 times root 15 times 1 6 times 30. Let's do the outside first. 3 times 2 is 6. 6 times 1, 6, it is 1. So inside the radical now, so that was the 3 times 2, right? These guys all went and became 1. I have 24, which is 4 times 6. I have 15, which is 3 times 5. And I have 30, which is 6 times 5. I just ran out of room, so I'll just write that right there. So in other words, this becomes 1 times root 4 times root 6 times root 3 times root 5 times root 6 times root 5. Well, let's just break down these a little bit at a time here. That was a 3. I have root 4. I'll write that in blue. That becomes 2. Root 6 times root 6 is 6. Root 5 times root 5 is 5. And left inside, so I have a root 3. Well, 2 times 5 is 10. 10 times 6 is 60. So I have 60 root 3. You guys try these real quick. Stop the tape. I'll come back in a couple seconds. Don't miss me when I'm gone. All right. Okay, I'll come back, I promise. Okay, so if you look at the first one here, I have negative 2 times negative 5 halves, which of course is 5, positive 5. And I have 48, which is 16 times 3. And I have 56. Both of these guys are inside the radical. 56 is 14 times 4. So all of this now is inside the radical. Well, the 5 is 5. Root 16 is 4. Root 4 is 2. I'm left with 3 times 14 inside the radical, which is 42. 5 times 4 times 2, that's outside. That becomes 40. So I have 40 root 42. Let's look at this guy, and I didn't write this one out yet because I think we need to do it together. 3 times 22 is 66. 66 times 1/6 is 11. And then I still have inside the radical 120 times 24 times 10. Let's break these up into some numbers that are helpful to us. So I have 11 inside the radical now. 120. Let's think here. How about 4 times 30? 24 is 4 times 6. Very good. And 10 we'll just do as 2 and 5, and you'll see why in a minute. That's 2 and 5. Okay, well, 11 is 11. Root 4 becomes 2, right? Root 4. This root 4 becomes 2 outside, and I'm still left with 30, which is 5 times 6 times 6 times 2 times 5. So I now have, in essence, I have a 6 squared inside. They can come out and become 6, so I have 11 times 2 times 2 times 6. The 2 5s can both come out. They become a 5, and left inside I still have this guy right here, a root 2. So outside it looks like I have 11 times 6, which is 66, times 10, which is 660, times 2, don't tell me, 1320, I think. You can correct me if I'm wrong. 1320 root 2. That was a tough one. All right. Hey, I think I'm done. Have a good night, folks. We'll see you soon. Bye.